Alright, so I mentioned when we were starting out moving from rectangular form into polar form that while I wanted you to be able to do it by hand, I think it's important to get the logic behind it. We can also do it on the calculator. Okay, now there is one or two little eccentricities about the way the calculator does it, but I'm going to work through a couple of examples now. I'm just going to go back to the examples I would have done by hand in previous videos rather than doing some from scratch. So we're going to know the answer we're aiming for here. So the very first one I did was 1 plus root 3i. And when I changed that into polar form, I got 2 cis 60. So let's just see how to do that on the calculator. We're going to go into degrees. So let's make sure our calculator is in degrees mode. It is here. So you're going to enter the A and the B part of the complex number. So the real and the imaginary part. So the 1 and the root 3. We're not going to put the I in. Okay, so just the 1 and the root 3. All right. So we put in 1. Then this XY button, then root 3. You'll see above the 8, there's like an arrow and an or and a theta. That's what we're looking to use here. So it's second function 8, and there's or is 2, and the angle, the argument is 60. All right. I don't need to press equals. It just does it for me once I press second function and 8. If you do press equals, just press back, and it will bring you back to what you entered. All right, so there's your 2 cis 60. Just moving on then to minus 3 plus 3i. So my A, my real part, is minus 3. My B, my imaginary part, is 3. So I'm going to enter minus 3 xy 3, second function 8. And here's our first little kind of odd thing the calculator does, okay? So the answer we know we're aiming for from when we did it by hand was 3 root 2 cis 135. It gives me my angle. My argument is 135. That's fine. It gives me the modulus in decimal form rather than as a surd. I want that as a surd, okay? So whenever you give something as a decimal, you're rounding off. You're losing a little bit of accuracy, okay? So I don't want to write this or as 4.24. I want to write it as 3 root 2. All right. So the way to do it is to square that and then square root it, and you will get it in surd form. You can write that down, 4.242640687, square it and then square root it. Your calculator does remember it for you though. It is in its memory now, but it's again a little strange. If you look above the RCL here, it's got an X. If you do a green X, so if you do alpha RCL, an X comes up, press equals, there's your modulus, the 4.24. Just stops you having to write it out and then and type it out again. So if you just square that, it's 18. So the square root of 18 is 3 root 2. Okay, so if you get your modulus in decimal, as a decimal like that, okay, that's not what you want. You want it as a surd. So do what I just did there. All right, just moving on then to a couple more. So we did 2 root 3 minus 2i, and we got 4 cis minus 30. Okay, so let's put in our 2 root 3 xy. So 2 root 3 out under the square root xy minus 2, second function 8, and I've got 4 cis minus 30. I've got my modulus, I've got my argument. We don't need to kind of worry about what quadrant it's in, and the calculator is set to give you angles between 0 and 180 when they're up here, and minus up as far as minus 180 down here. Okay, so it will do that for you. You don't need to worry about what quadrant it is in. Just moving on then to this one here, I've got minus 4 minus 4i, so minus 4 xy minus 4, second function 8, and I've got my something cis minus 135. I've got my minus 135, but again, this is given it to me in decimal form. I want 4 root 2 here. Okay, so this 5.65 whatever is stored in the memory as this x above the RCL. So alpha RCL. You can just square it now, but maybe just press equals just to check that it's there. X squared is 32. So square root of 32 is the 4 root 2 that I got there. Okay, so it's perfectly fine to convert them on the calculator like that. Just be careful with decimals. Okay, so use what I did there, the alpha RCL, square it and square root it, and that will give you your modulus in surd form.